Hi, good morning. In today's video, I'm going to do the very important lesson regarding the basic trigonometric identities. In this lesson, I will have two videos. In the first video, I will do the part number 1, which is the theta between 0 to pi, and the second video, I will do the theta between pi and 2 pi, okay? Now I have chosen unit circle in the coordinate plane with the origin O and x as a horizontal axis and y as a vertical axis, okay? So I have this circle, I have the point M is turning around the circle, okay? At the point M, I will do the projection of the point M on OX axis, okay? I will have a right triangle, okay? Now I am allowed to use trigonometry formula in this triangle, okay? As you know, in the right triangle MHO, we have sine theta is MH, which is y, by extension on vertical axis, okay? Y over r, which is opposite over hypotenuse, okay? Opposite equal to y over r. Since r equal to 1 because of circle, okay? So that's mean y equal to r multiplied by sine theta. So y equal to sine theta. Now we have first equation. Let's move on to calculate cosine theta. Cosine theta, as you see here, is an adjacent over hypotenuse. Adjacent is a x, which is OH over r, okay? So x over r equivalent x equal to r multiplied by cosine theta. So x become, since r equal to 1 because of circle, so x equal to cosine theta. This is the second equation that I have. So I have x equal to cosine theta, y equal to sine theta. Y is this distance, okay? This is y. This is x, OH equal to x, equal to cosine theta. Y equal to, let's call it m prime, for example, right? Here I'm going to calculate cosine phi, which is cosine of pi over 2 minus theta. As we have orthogonality here, because the vertical y and vertical axis make pi over 2, okay? And this one, this angle phi equal to pi over 2 minus theta, which is cosine pi over 2 minus theta equal to now we have the adjacent over hypotenuse. Adjacent, this distance for the cosine phi, okay? Now let's move on to calculate cosine phi, okay? As you see here, since we have orthogonality, because the vertical axis and horizontal axis make pi over 2, okay? So phi equal pi over 2 minus theta. Now cosine pi over 2 minus theta, which is phi, equal to this distance is adjacent, which is y, over hypotenuse, which is r. So since r equal to 1, so y equal to cosine phi. Same time cosine equal to cosine pi over 2 minus theta. What is y? Y we already calculated. It was sine theta. Sine theta, okay? Same thing with the sine phi. Sine phi equal to pi over sine of pi over 2 minus theta. Just in this time, I'm going to do the opposite over hypotenuse. Opposite in this case is a m prime m, which is x. Okay, if you do the projection on horizontal axis, you will find x. M prime m equal to x. which is x over r. Since r equal to 1 because of circle, so x equal to sine phi, sine phi equal to sine of pi over 2 minus theta. Okay, now I verify the connection between sine and cosine. So the cosine pi over 2 minus theta equal to sine theta. The same thing, sine of pi over 2 minus theta equal to, as you see here, we found x equal to cosine theta. Now the connection between sine and cosine, since there is orthogonality, okay, so we have cosine pi over 2 minus theta equal to sine theta. Here in inverse, we have sine pi over 2 minus theta equal to cosine theta. Okay, if you take a look again in this triangle MHO, this is a right triangle. Now I'm going to apply the Pythagorean theorem. So in triangle OMH, so we found r squared equal to x squared. X squared is this distance OH, okay, because we have a right triangle, plus this distance which is y by projection, okay, by extension on vertical axis. We'll find y plus y squared. Since we have r equal to 1 because of the circle, we fixed already r equal to 1, so that's mean 1. Okay, as you see here, if you raise number 2 as a power for the x, so we found x squared equal to cosine squared because of this, because we have this equation, plus y squared, y equal to sine theta, y squared is sine squared, okay, sine squared theta, which is 1. That's what I found here. So my connection between sine and cosine, 1 equal to cosine square theta plus sine square theta. Okay, now this is very important and useful equation. Okay, now let's move on to calculate cosine theta plus pi over 2 at the point theta plus pi over 2. By doing the projection of the point N on horizontal axis, we will find a right triangle at the point H prime. Okay, also we have another triangle, is a right triangle at the point H. Okay, so both triangles, so both triangles are congruent. Okay, because both triangles are right triangle, and also they have same angle theta, because we are calculating theta plus pi over 2 due to orthogonality. Okay, and also we have hypotenuse of for each triangle are the same distance. Okay, which is r equal to 1 because of the circle. So now cosine theta plus pi over 2, cosine represents horizontal axis x, is located in the negative direction. Okay, minus. Okay, so the cosine equal what? The cosine, this distance OH prime. I'm looking for this distance because they represent cosine in this case at this point theta plus pi over 2. Okay, OH prime equal to this distance MH due to the congruence of both triangles. MH is y by doing the extension on vertical axis. Okay, so this distance what I'm looking for, which is OH prime represent cosine, is y. Okay, so the distance that I'm looking for is y over hypotenuse. Since we have the cosine is located in the negative direction, so minus y, so equal to minus sine theta. Okay, now let's move on to calculate sine theta plus pi over 2 at the same point. So sine theta, we are doing the same thing what I did before with cosine. So the sine theta plus pi over 2 at this point by doing the projection. So sine represents this distance un prime. Let's move on to calculate sine theta plus pi over 2. Okay, we are doing the same thing as we did with cosine. So as projection on vertical axis, you will see n prime. We have I'm looking for this distance n prime, which is represent sine at this point. Okay, sine theta. So sine of theta plus pi over 2 is n prime. n prime equal to the distance due to the congruence of both triangles. Okay, is a x. Since we have sine theta is located in the positive direction, so it will be positive. So positive x. Okay, because this distance equal to x, not to y. Okay, y you have this is y, very small distance in this case because theta it was a small. Okay, so x equal cosine theta because we already evaluated. Okay, so I have two equations now. Let's call it third and fourth equation. Let's move on to calculate cosine and theta at the point theta plus theta minus pi. Okay, theta minus pi. As you see, we are doing the same thing by doing the extension on horizontal axis, okay, and vertical axis as well. So, okay, so now we are dealing with distances in this circle. Okay, because once we establish the first equation in the first equation, this equation, both equations x, which is x equal to cosine theta and y equal to sine theta, will be valid. Okay, at any point. So because we already verify x equal to cosine theta. Okay, this is just the angle keep running around the circle. You can calculate sine and cosine at any point you want. Okay, so let's move on. So let's move on to cosine. Start with cosine theta minus pi. Okay, remember one thing, cosine between pi over 2 and pi is always negative because it's located in negative direction. Okay, is located in negative area, but the positive from 0 to pi is always positive because when you do the projection, when you do the projection on vertical axis, you will have all you have the sine theta is a positive. Okay, so cosine theta minus pi equal this distance. It represents cosine theta. I'm looking for this distance. What is this distance? Let's call it c. Okay, c prime. This is c prime because we have projection. Okay, so now the cosine theta minus cosine theta minus pi equal to c prime. This distance. What is this distance? Is equal to x, because I have both triangles are congruent, the first one and the last one. Okay, you see it, because they have a same hypotenuse distance. Okay, and then they have same theta. Both triangles have right triangle. Both triangles have right angle. Okay, which is 9 pi over 2. Okay, so cosine theta minus pi equal OC prime equal to x, but minus x because it's located in the negative area. Okay, so minus x, we already calculate x equal to cosine theta, so equal to minus cosine theta. Okay, now I established fifth equation. Okay, I'm going to calculate sine pi minus theta at the same point. So the sine, as you see the sine here, if you do extend this point on vertical axis, you will see this distance equal to this one, which is y. That I pointed before. Okay, this one I have pointed before. This one y equal to sine theta. Okay, So this distance equal y equal is positive direction, because so y equal to sine theta. I done with the half of this circle from 0 to pi. In next video I will continue with theta between pi and 2 pi. Okay, this is good place where I can stop. I will see you in next video.